Okay, here we go. We're in Module 9 now. And Module 9 deals with a linked list class. Now, I think I saw somewhere where it's two-way nodes. So this is a doubly linked list, meaning not only does each node have a package or the data that exists in it and a pointer to the node behind it, it also has a pointer to the node in front of it. Now, they all have two nodes with the exception of the start and at the end. So the first node and the last node don't have anything to point to in those directions. So we can technically work our way all the way to the end and then come back. Either direction we can navigate. And we don't have that in a singly linked list. So in this one, they've got the iter function, and they want us to go in, and in the list of functions, as we come down, they gave us a list iterator function and a class list iterator. So with that said, in our list iterator, we need to go check at the beginning, we need to check at the end, and we need to look forward, we need to look backwards. So that's what these are. Is there something next? What's next? Was there something before us? What was it? Let's replace something. Let's insert something in between two existing nodes, and let's remove a node from its current position. And that would then join the one before it and the one after it together. So I love to compare these two train cars. And at the beginning, or the front of each train car, there's something that says what's connected in front. And at the back of each train car, there's something that says what it's connected to behind it. And if every car has that, then you know what's ahead of you, you know what's behind you. We just ignore the front of the front and the back of the back. Okay, so let's start. And there's something that they've left off. And I don't know if they left it off intentionally, but I'm so used to including it that I'm going to include it because at some point they're probably going to say, hey, you need to create this. So let's go ahead and put it in on our own. Say, is there a first method? We're going to define what first is, and this returns the value of the beginning of the backing store. So this will return the beginning of it. So we gave it a name, and we'll say self.cursor equals self dot backing store dot head, and the next one. Okay, and then we'll say self dot first. And that'll do. There's my normal. Enter key didn't work like I want it to. So we've got our init. We've got a first. Bring that so we can see it. So after first, traditionally, I'll have what's next. So let's do this has next now. Just copy that. Come in here. I'll put a self in there. And has next. It's not going to be difficult. We'll just say return self dot cursor, and we say I want to know whether or not there. I'm checking to see if we're not in the front. So I want to find out, true or false, is there something next? Right. If the cursor is not the head, then yes, there's something. So here's our next, or has next. Now we need a next. Okay. Oh, I forgot def. Find it. All right, so next, we've got not a ton of stuff that we've got to put in there, but we've got to deal with what if there's nothing next. This one just look to see are we at the front or not, and this one's now going to look and see what is next. So now we have to confirm, is there something next? To do that, we're going to say if not self dot has next. So if it doesn't have a next, we have a problem. So essentially, we're going to run this function. So if it does not have next, go ahead, do that, and at this point, I want to raise that traditional error that we'd had time and time again. Attribution error, or attribute error. Why it didn't turn red. And we'll just give it a message. Say no item next in list. All right. So we, on this condition, decided, yeah, there's nothing there. So the next one, self dot not count is not equal to self dot backing store dot get not count. There. Let's see, phrase. Oh goodness. There it goes. I'm just going to copy this attribution error and modify it. And this one's modification of backing store. Okay. So got that. Let's set to see what the last item, or set what the last item is. Self dot cursor equals self dot backing store dot head, and then we need self dot last item position. Okay. Now let's come down. Got so many functions we got to do in here. So we got has next, next. Let's look at the end. We'll do last. Try and get the easier of them out of the way first. There's a bunch of them. So we've got last, and for last, I want this item right here. I missed something. I need to take all this, cut this out, paste it in here, and back where it was, that's where I want to return enter key. A couple of things. I can't remember if I deleted them or I just didn't type them. So I want for next, I need self item position for the last position equals self dot cursor And then self dot cursor equals self dot cursor dot next. Now we've got our return. Going to return that. Go get the last position. We found where it's at. Go get the payload that's in it. Return that. So that's what's next. Alright, so beyond that, our last item is similar. So we had self.cursor is the backing store head. Self.last item position equals none. That'll by default return our value of is this last, moves an item to the last item. Okay, so we have last def has previous. Okay, so on has previous, down self. Just jump into the return. And for previous itself, cursor, and then from cursor we go to previous. Cannot be equal to self.backing store head. So is that condition true or false that they're not the same? If they're not the same, then there's a previous. If they are the same, then there is nothing ahead. You're saying that we are at the head of this linked list. Okay, so def, so we did has previous. Let's just do previous. So for previous, we're going to do the same thing we did here. I'm just going to modify it a little bit. No. Okay, let's save this a little bit of time. So check to see if there's a previous. No. let's do self cursor. Previous. And then I'll do this here. Do the last item's position is where I'm at. And then I want to return, just like we did there. Okay. So there's the previous part. Okay, after the previous, let's go to F, insert, self, I'm going to tell it what we're going to insert. Now this is one that we've done before. You could probably pop open one of these existing files and grab it out of there. No, I don't want to cut that corner. So we'll start out and check. We did it before. Grab this line of code right here. So I'm going to go check the mod count. So the legal modification of the backing stores, same thing, or the list has been modified. So we're done with that condition. I want to check and see if self dot the last item position is none. Self dot backing store dot add item. If our current position, or what we're looking at, is last item position, and we add whatever it is, and go else. I need to create a new node. Make sure that it's a two-way node, doubly linked list. It needs the item. It needs self dot last item position dot previous, comma self dot last item position. That's it. There's our two-way node. Think about that. One is the payload, the other is where the thing before it is and where the thing after it is. So from there, system's glitching on me again. Okay. We've got that in. Let's go ahead and I did the new node. Now we need last item. Position dot previous dot next equals new node self dot position dot previous equals new node self dot backing store dot size plus equals 1 self dot last item position equals none. Back up to straight below that else where that started. Self dot, where's my mod count? There we go. Plus equals 1. Alright, so that took care of insert. Last one was remove. Now, let's see. I need this. Make sure what we've got going when we try to start. I want to raise an attribute error. If that's the case, current positions undefined. Okay. And no, let me switch this up and try a different test here. I'm going to last. No. another one down below it then. Do if self.mod count and make sure that is not equivalent to self.backing store dot net count. I need to raise an error. And let's modify it illegally. So from here, I'm going to say item equals self dot last item position dot data and condition in here self dot last item position it's the same as self dot cursor. Then I'm going to say self dot cursor is equivalent to or equals self dot cursor dot next. I'm going to do the other side. Self dot self dot. Now I did. What's next? Self dot last item position dot previous dot next equals self dot last item position dot next. Self dot last item position previous I just did that one. Do the next one. Dot previous equals self dot last item position this one's next, this one's previous. Should have got it sorted. And then we'll just do self backing store. Change the size of it. plus equals. Oh, no, I'm doing minus there. Too many of these videos in one day. Self.backing store. Include mod count. Self dot mod count plus equals 1 minus equals plus equals self dot last item position equals none. So got remove, got insert. I don't have replace. Let's go ahead and add previous, or after previous. Let's add in this replace. Okay. If it's none, with this error. And if mod count with modified illegally. And just type the last of this in. This is self dot last item position dot data equals item self dot last item position equals none. I'm going to pass it item. Pass in item, and that's what we're putting in there. Alright, now let's test the waters and see where we stand on this. I failed every one of them. Go look and see what I can see. There, I got an error right there. It's plus equals. Let's try it again. Now, where's my error? It looks like I have somehow pasted this exception in the wrong place. So at the beginning of init, I should have self.backing store. Now I've got to set all this stuff up when it gets created because it was hanging on me. Because this for whatever reason wasn't there. Now, I'll run and see if it throws me an error about where that indentation issue on this somehow. All of my stuff is in way too shallow. Tabbed in too far somehow. I'll just shift tab out and make sure I'm lined up. Yeah. So there's that def, here's the class definition, and now we're all in line. So all in line, that indent's there. Let's check again. Okay, I had one more typo. The end of this first definition, I had that line. I needed self.last item position equals none. There's still an issue which doesn't seem to be over the top. Let's see. I see what my problem is now. It's the type of error. So on 134, previous, I've got attribute error, and that is actually a value error that it's looking for. And so is the last one. So it has next. Yeah, has next. The self dot has next. Let's see if that resolved it. I got one left, and that's in remove. Right there. And let's watch that one go away. Come on. Okay, I got a couple issues in this remove. That still should have stayed attribute error. I didn't think before I made it a value. This, I had an issue here. It's not equivalent. Previously, it was supposed to be. Now, the last thing I did was right here. This is in too far. So I shift tab and move it back. Let's see, that should take care of my remove function now. Yeah, that got got it. So that got us through it. This one took a whole lot more than 3-4 minutes that some of the ones last module did. We're through it, and I'm hoping that it'll cover us on some of the things we got coming up in 9-2. So that said, scroll up in case you need to pause at any point to check your indentation, issuing any line of code. And that's as far as we went. We went from there. No, we did the init too. And this was already set for us. All right, I'll see you in 9-2.